Hi guys, welcome back to another data analysis session. I'm Gabriel with you and I'm a data analyst at Data Playground. Over the last two videos, we learned how TradeFlow's data is split, across eight connected tables. We learned select, we learned where, the group by, and the order by. But if you've been paying attention, you would have noticed something which is a little frustrating. You notice that every query that we've written so far, it only looks at one table at a time. So, for example, if you want a customer's name to be next to their order, we've had to run two separate queries and try to manually match them up ourselves. But in this video, that's going to change completely. Today, we are going to learn how to use the joins. And joins is like, it's one command that it lets you pull data from multiple connected tables into one single query. So, to a very large extent, joins is a highly important skill in SQL, and once you understand joins properly, everything else through this section, SQL is going to become a lot easier because almost every real business question requires you to pull data from more than one table at once. So let's get straight into it. Uh, Remember to open your DBeaver software on your laptop. So as usual, we are simply going to create a new script. We go to, I'm going to close this. We go to the TradeFlow, right click, and SQL editor, and new SQL script. So let's get straight into it. Now, first, let's look at the problem that we always have, right? Because that's the only way this is going to make sense. So first of all, I say select asterisk from orders where customer ID, oh, that should be an underscore there, ID is equal 1042, and then control enter. Now when you run this code, we've we've actually seen this before. We did this in our first video on SQL, right? To orders, but there's no customer name anywhere in sight, just the number 1042 to represent customer ID, and we wouldn't know which customer this actually represents unless we have to run another query for that. So if I handed you this result and I ask you whose orders are these, you'd have to try to probably run a second query against customers. You try to find a name and you then mentally connect it to yourself, and that's exactly what we did in our first video. It basically works fine for one customer, but then the moment you want answer for 2,000 customers at once, nobody is going to have to run 2,000 separate queries and then try to start matching them up by hand. So this is the problem that using joins solves. A join tells the database that you should, combine rows from two tables using a shared key, and then give me back one single result that has both tables information sitting side by side. So we are going to start by looking at the inner joins. We are just going to combine two tables, right? We want customers' name sitting right next to their orders. And so this is exactly how you can do that. For example, we can say select customer name, or sorry, select from the customers table rather, customers dot customer name, orders dot order ID, order dot order, oh, this should be orders again because it's from the orders table, right? Orders dot order dates, right? And we'll probably want to select the orders dot order status, orders dot order status, and we want to select this uh, from customer stable, right? And then what are we joining it to? We are saying join orders on customer customers dot customer id is equal orders dot customer id. Now, before we run this query, let's try to understand what's going on, because uh, this is quite long and it's probably looking complex. We've never done something like this before. Now, the the first line that has to do is select customers as customers name, others dot other ID, others dot other dates, others dot other status. We are simply trying to choose columns from two different tables now. So we write the table name, and then we put a dot and then the name of the column that we want to pick. So this makes it a lot less ambiguous, makes it completely unambiguous, right? Which table each column is coming from. And so then from the part where we have from customers, right, we are simply it's the same as always. We are simply trying to pick our starting table there. Then you saying join others. Now this is a new part. We are telling the database to bring in the others table too. We selected our starting table, join. Now we are telling, okay, bring in the others table too. Then the part where you have on customers does customer ID, right, is equal to others dot other does customer ID. Now this is the most important part of the entire query. We are basically saying, okay, so on, for example, tells the database how these two tables are related. Match up the rows where customer ID equals the others customer ID. That means in the customers table you have customer ID as a primary key. In the others table, you have customer ID as a secondary key. So these 2 points that appear in both tables match their values together. That's the meaning of that particular statement on customers dot customer ID is others dot customer ID. Now that's a foreign key relationship which we already learned from uh the from our very first video on SQL. So we're just going to run this and then present, and now we can see exactly what's happening. If we observe the rows now, we find out that each row, right, now has a customer's actual name sitting right next to their order information. So you don't have to do any manual lookup again. You don't have to write a second query. You don't have to try to match things up by hand. The database has already done this for us using the 10,000 orders in one single query. So this particular type of join that works this way is called an inner join, right? Join by itself, that's using this keyword join, actually just refers to inner join. So what we just wrote, and if we try to even rewrite it again, it just basically means the same thing. If we decide to say, okay, let's change this to inner, it's still basically the same thing that we are trying to do here. We still get basically the same result. So by default, you either have join here represents the full inner join. It's actually clearer to read anyway whenever you write inner joins fully instead of just writing join. But that's just a sign. It's something that you should know, that join still represents inner join. Now, already looking at this, if we had a lot more work to do, having writing out the full names of each of these tables might become very, very tedious. And that's where the use of aliases come in, because if you have to type customers as customer name and others as other ID over and over again, is going to get very, very tedious, especially once we start maybe joining three or four tables together later. So SQL gives us an easy way out through what we call an alias, right? An alias is like a short nickname for a table, and it's defined right where you first mention it. So we can rewrite the whole of this query. We are going to rewrite it now, but this time we are going to be making use of aliases. So how do we go about that? I'll just say select c dots. Oh, okay. I don't think I want us to bother ourselves too much with typing out the full stop. I'll just copy this. I'm going to say Control C, and then I'll just paste it here, and then I'm just going to edit what I want here. So I'm going to say select C dot customer name, and then I'm going to say O dot order ID, O dot order dates, O dot order status from customers C, right? That's where I've defined it now. Join orders O, right, on C dot customer ID is equal O dot customer ID. Now I'm going to just run it, and then we basically have the same result, right? Notice that we have something like customers C, right? And then we have orders O. What that means is that that's the point where we define that we are okay. We're trying to say that C should represent customers, O should represent orders. So we didn't have to be typing it full in every other place again, right? So we are just saying call customers C for the rest of this query and call orders O, right? Then everywhere that we would normally have to write, the full table name, we just use the short letter instead. So it's the same result, and we just have far less typing to do. So in real SQL code, take notes, you probably see this play out. So try to get comfortable with aliases now. Now, going deeper into this, because real business questions would really stop at just two tables, right? So let's try to see if we can pull in exactly which products were ordered and not just which orders exist. Now remember that from our first video that we had, order items is what connects the orders to products, if you remember, if you have that in mind. So how do we go about this now? We are going to say select c dot customer, uh, let's say c dot customer name, o dot order id, p dot product name, and oi, right, dot quantity. Remember, all these are aliases, right? Now we are selecting, okay, from customer C. You've defined that there, right? And then we are going to say, okay, join orders O. Define that there also on C dot customer ID is equal O dot customer ID, right? Again, join order items OI, right? On O dot order ID is equal. Okay, I think I should bring this to a new line because it doesn't make any sense at all having this here, right? Yeah, I think this is much better, right? So O dot order ID is equal OI dot order ID, and then join products. Okay, I should still bring this down here, please. Join. Why you okay? What did I just do? Control Z, Control Z. Control Z. Wait, what? What's this? I didn't even look at what I was typing. Is OI and OI is that OI dot other ID? Should be OI dot other ID. Did I? Yeah. Man, sometimes I'm probably not even looking at what I'm doing. Okay, so join products P on uh, OI dot products ID is equal P dot products uh, products ID close and let's see what reason. Select customer name, uh select C dot customer name, O dot order ID, P dot product name, OI dot quantity from customer C, join orders O on C dot customer ID is equals to O dot customer ID, join other items OI on O dot order ID is equal this should be small letter OI dot order ID. Join products P on OI dot products ID is equal P dot product ID. So right, let's run this code. All right, so we've successfully joined three tables together, right? With or is it 4 tables? 1, 2, 3, 4. We actually just successfully took 4 columns from uh about 4 different tables together because we have the customers table, we have the orders table, we have the products table, and then we have the other what's a table. I think that's OI represents the other items table, right? So okay, let's walk through what we just built. Now we start at customers, right? Now we join the customers table to the orders table by making use of the customer ID because that's what exists in both tables. Like I said, customer ID is a primary key in the customers table and it's a foreign key in the orders table. That's what we use in joining the orders table and the customers table together. Then now we join the orders table to the other items by making use of other ID, right? Now, other ID is common it's common to the orders table and then the other item. Other ID is a primary key in the orders table and it's a foreign key in the other items table. Then we join other items to products using uh, the product ID. Now, product ID is a primary key in the products table and is a foreign key in the other items table, right? So we made use of 3 joins chained together, and then you find out that we are actually just trying to follow the same path we marked out back in our very first video. So when we run this particular query, now we can see the customer name, we can see the okay, let me expand this. We can see the customer name, we can see the order ID, we can see the product name, and then we can see how many of such products were bought by those customers. So this is a really powerful query because we just use one query to walk through the entire chain. We use one query to be able to connect the tables together, right? Connected customer to their order, right? And then to the specific products they bought, and then to how many of these products that they actually bought. And this is how most of your query that you'll be working with as an analyst, this is how most of them are going to be shaped. Now, the next thing we're going to try to look at is the left join, right? Now, there's something that you should know coming from our very first video. Not every order in TradeFlow's database has a delivery record. For example, if an order was cancelled, then it never got shipped. So that means that if you have an information for an order that was cancelled, on the case of delivery, there will be no information for that particular order because it never got one, it was cancelled. So having that particular order in delivery, there will be no information for that. So let's try to see what happens when we make use of inner joins. You understand? When we try to, okay, let's try to use inner joins with delivery, because remember that what inner join does is to match up the tables together. Okay. Enough of the many talk. Let's just see how to apply it. So I'm going to say select o dot order id, o dot order status, and d dot delivery status from orders o join deliveries d on o dot order id is equal d dot order id. And then I'm going to run this particular code. So I'm going to, of course, let's see. What did I do wrong? Oh, okay, yeah, I've seen this already. Made mistake here. That doesn't make any sense at all. So control enter. Okay, all right. So we have a table here that is showing order ID, order status, and delivery status. Right now, if you remember, our original orders table had 10,000 rows. So let's test this now. Let's run a total row count so we don't have to start scrolling to find every single thing that we need. So I'm going to say select count. We want to count the result that just came to us right now, and let's see what we have. Select count from orders o, right? And then I'm going to say join delivery d on o dot order id is equal d dot order id. Right, I'm going to press enter. Now what do we have? Remember our original counts for the case of order, for the order table. In fact, for every product that was ordered was 10,000. But now when we try to join the orders with the deliveries, we are having a count of 9,500. That tells you that the orders table probably have 10,000 records. But in the case whereby you had cancelled, nothing was recorded on the delivery. That means that the delivery table had about 9,500. So when you use the inner joins here, it's only going to consider cases whereby there are matching values in both tables. So you are not going to have 10,000, but rather you have 9,500, and then that means that the remaining orders are overlooked automatically because there's nothing to match them with in both tables. So now your count is 9,000, uh 9,500. So we're basically getting fewer rows than TradeFlow's actual 10,000 orders. And that's, like I said, this is because an inner join, it only keeps rows where both sides just match. So basically any order that does not have a matching delivery record, like let's say our cancelled orders for example, it's just going to disappear from the result entirely. And sometimes as an analyst, that's probably exactly what you want. But most times, you might specifically want to see every order, including the ones with no delivery yet. And so, to be able to investigate why, you understand, you might want to say, okay, I want to see all the orders that do not have deliveries. So that means I want to see the full 10,000 rows. And it's because, okay, you want to be able to draw a quick comparison, and then you want to be able to investigate why are there 10,000 orders and 9,500 deliveries, right? In that case, you'd have to make use of left join. What the left join does is that in places whereby there are no values, it just basically puts null for you. So you still have your complete 10,000 rows, but you'll be able to see the places that are actually empty. Okay. I think I'm probably talking too much. Let me just show you what I mean. So I'm going to say select. Okay, you know what's going to happen. Let me just take the whole of this code because it just basically seems now about to type right now, so I don't have to type everything from scratch again. So Control V. But now I'll change this to left join. Let's see to make sure I've written about o dot order id, o dot order status, d dot delivery status from others o, left join deliveries d on o dot order id is equals to d dot order id. So I'm going to run this entire query, right? So what can you see? For example, in case of order status, delivery status would have had nothing recorded there. So now SQL has returned null. That means there is no corresponding delivery record for this order ID. And if you scroll down, you find multiple cases where you having null also. So you still have your full 10,000 rows now, right? But cases whereby there's nothing matching both tables, you just see null written down there. So that's how the left join works. And by the way, null simply means that you have an empty result, right? It just means there's genuinely nothing there to show. It's not zero, it's not blank text, but just a complete absence of a value. So left join, keeps every row from the table on the left side of the join, and in this case it's the orders that's the left side, right? So without notes, it finds a match on the right side. It just keeps everything as on the left side. And like I said, this is quite useful for the kind of investigation that we've been doing right now. Let's okay. Let's try to use this for something that feels real, right? Let's find every order that has no delivery record at all. So that let's try to actually answer a business question, right? We want to know, okay, which orders actually have no delivery at all. So I'm just going to say select o dot order id, o dot order status, right? From orders o, right? I'm going to say left join deliveries d, right, on o dot order id is equal d dot order id, right, where d dot delivery id is null. In this case, you remember what where does. Where helps in filtering, right? So we want to filter by null values now. So we can now see the 500. I expect to see five now. Thank you very much. Remember we had 9,500 here that time. So these are the corresponding 500 records that had cancelled. These are their order IDs: order 2, 10, 48, 57. We can see the exact order IDs that had cancelled and other status of cancelled. These records were having no value in our delivery table. It just basically helps our investigation. We're able to, actually answer a real business question here. We're able to see we're able to specifically now ask for rules where that value is missing, right? We can't, and mind you please, we cannot use a regular equal sign to check for null. It needs this special phrase is null, right? Okay, so we can see what's cancelled now, and it's just with the help of the left join. So basically all we've done today, what I like you to take notes of before our next video and sit with and try to repractice on your own. A join combines rows from two or more tables using a shared key, right? And it's this shared key is defined first by using the on clause, as this guide has here on. We did that every single place. So it's just exactly the foreign key to primary key relationships that we mapped out back in our very first video. Then an inner join, right, or just join if you like, but professionally it's always better to just write inner join. I should have been doing that all through this video, but anyway, just think of that. Inner join only keeps rows that have a match on both sides. Left join keeps every row from the left table and fills in null wherever there is no match on the right table. And that's very, very perfect for finding gaps and missing relationships. Then one other thing that works today was the aliases, like for example letters like C or O, right? It just helps you to keep multi-table queries readable instead of repetitive. So now you have the most powerful tool in SQL, and from here on, almost every query we write is going to involve pulling data from more than one of TradeFlow's 8 tables at once. So next time we are going to go deeper into this. We are going to look at subqueries where we are going to learn how to nest one query inside another to try to even answer more advanced questions. So thanks for watching this video. Please do well to like this video, share this video, and subscribe to our YouTube channel. I'm going to drop the link to the playlist if you are just starting out your career in data analysis and you want to know exactly where we started from scratch, how to think like an analyst down to spreadsheet, and now we're in SQL or SQL. I'm going to drop the links to the playlist and you can follow through. See you next time on this same channel. Goodbye.